Hello everyone, let me introduce myself. My name is Resti Wahyunovianti and my friend Zara Nurul Zahraini. On this occasion, we will explain about acid and base. This is outline that we will explain. 1. Definition of acid and base. 2. Characteristic of acid and base. 3. Theory acid and base. 4. Acid and base solution test. 5. Application of acid and base in everyday life.
A. Definition of acid and base solution. The acidity and the basicity of a substance depends on the amount of hydrogen and hydroxide ions present in the substance and the degree of ionization of the substance. The term acid comes from the Latin acerum, which means vinegar. An acid is a chemical compound that when dissolved in water will solve with a pH less than 7. A base is a chemical compound that absorbs hydronium ions when dissolved in water. Bases have a pH greater than 7. Acid can be divided into strong acid and weak acid. Bases are divided into strong base and weak base. Next.
B. Characteristic of acid and base. Characteristic of acid. 1. Have a sour taste. 2. It can change the color on litmus paper to red. 3. Are corrosive with its way this acid can dissolve various types of metals such as zinc and aluminum. 4. Having a pH of less than 7. 5. Can deliver an electric current. 6. When dissolved, this acid will release a hydrogen ion. Characteristic of base. 1. Has a bitter taste. 2. Can change the color on red litmus paper to blue. 3. It can also neutralize acidic properties. 4. This strong base is caustic. 5. When exposed to the skin, such as sodium hydroxide, will feel sore and can cause injury. 6. Having a pH of more than 7. 7. If dissolved in water, the substance will be able to produce hydroxide ion. 8. Are electrolyte.
Arrhenius acid-base theory. This theory was first put forward in 1884 by Svante August Arrhenius. Acid is a compound that releases hydrogen ions when dissolved in water. Base is a compound that releases hydroxide ions when dissolved in water. Example: 1. Hydrochloric acetate, which is very soluble in water, breaks down into hydrogen ions and chloride in waters. 2. Sodium hydroxide is a base because it is an ionic compound that dissociates into sodium and hydroxide ions when dissolved in water. Lack of Arrhenius theory. Arrhenius acid-base theory only applies to solutions that use water solvents, while non-water solvents are no longer valid. Some compounds are acidic or basic but do not contain hydrogen ions or hydroxide. Arrhenius cannot satisfactorily explain the acidic properties of certain salts, such as aluminum chloride.
3. Lewis theory acid and base. According to Lewis, acid is a substance that acts as a recipient of an electron pair. A base is a substance that acts as an electron pair. Acid-base reactions, according to Lewis theory, are related to the transfer of electron pairs that occur in coordinating covalent bonds. The following are example of reactions from Lewis acid-base theory. Look at PowerPoint. Lewis acid-base theory broadens the understanding and doesn't conflict with the existing acid-base theory, which can support the previous theory. According to Lewis, acid-base is not only limited to the release of hydrogen or hydroxide ion or proton transfer, but compounds whose reaction involve electron pairs. For Franklin theory, acid and base, the solvent system purpose Franklin was the development of Arrhenius acid and base concept, which he further expanded to use several solvents. According to Franklin, acid is a substance that produces cations from solvents. Base is a substance that produces anion from solvents. Neutralization: acid plus solvent base. Plus in water ionization, which produce hydronium ions and hydroxide ions. The liquid ammonia solvents will also produce ammonium ions and amide ions. The two ionization reaction can be shown by the equation. The addition of strong acid into the water will cause an increase in the concentration of hydronium ions and decrease the concentration of hydroxide ions from water equilibrium. Conversely, with the of a strong base will cause a decrease in the concentration of hydronium ions as an increase in hydroxide ions from water equilibrium. Likewise, if ammonium salt is put into a liquid ammonia solvent, the concentration of ammonium ions will rise, and the concentration of amide ions will decrease from its ammonia equilibrium. Therefore, the ammonium ions acts as an acid and the hydroxide ion acts as a base.
Acid-base solution test. To determine a solution that contains acid or base is to use an acid-base indicator. The indicator is a complex compound that can react with acid or base. 1. Natural indicator. Natural indicators are indicators that are made using plant extract such as flowers, tubers, fruit skins, and colored leaves. 2. Universal indicator. Universal indicator is a mixture of various indicators that can show the pH of solution of changes in color. Next. The example of universal indicator. Litmus paper. The paper here is strip absorbent paper and each indicator box of this type is equipped with a color map. Solution. A solution has a different color change if reacted with acid or base. The pH range and color are explained in the following table. pH meter. The pH meter is an electric device or can be said to be a more modern tool for measuring the pH of a liquid. Next.
Application of acid and base in everyday life. Application of acid in everyday life. Example of strong acid in everyday life. Chloride acid. Chloride acid is used as a steel preservative, the production of organic and inorganic compounds, pH control, ion exchange regeneration, scan processing, ordinary salt purification, household cleaners, building construction, acidification of oil wells. Chloric acid. Chloric acid is used as an oxidizing agent. Example of weak acid in everyday life. Cyanide acid. Cyanide acid is used as fumigation, facilitating the metal industry's chemical compound synthesis, making for cyan blue and gold extraction. Tamarin acid. Tamarin acid is used as a raw material for making fluorine and Teflon. Other uses are as electrolyte liquids in processing aluminum minerals and for painting glass. Application of base in everyday life. Example of strong base in everyday life. Sodium hydroxide. Sodium hydroxide is used for paper making from wood, making organic chemical and surfactant production. Lithium hydroxide. Lithium hydroxide is used for the production of lithium gases, carbon dioxide removal, and heat transfer media. Example of weak base in everyday life. Aluminum hydroxide. Aluminum hydroxide is used as a manufacturer of various other aluminum compounds. Iron 2 hydroxide. Iron 2 hydroxide is used as catalyst, pigment, thermite, and hemoglobin.
So that is our presentation about acid and base. Thank you for the attention and see you.